So in this video we'll be introducing what is meant by a surd and also showing you how to simplify them. Now before we get started on introducing surds and simplifying them, I recommend that you have a go at these two questions. So if you want to pause the video to have a go at them, and then I'll go through the answers. So in terms of the first question, it's asking you to write down the first 16 square numbers. So what do I mean by square numbers? It means basically 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, etc. And so all you need to do is write down what those answers are actually going to be. So 1 squared is 1, 4, 3 times 3 is 9, 4 times 4 is 16, 25, 36, and then you're going to have 49, 64, 81, 100, 121, 144, 169, 196, 225, and 256. Now for question 2, it says write down the following numbers as a product, which basically means multiplying of two numbers whereby one is a square number. And obviously one of the rules are that you can't use number 1 and you want to aim to use the biggest square number. So what you want to do is you want each of these to multiply as a sum. In other words, you want to find two numbers that multiply together to give you that number where one of them is a square number. You want it to be as big as possible. So you can only use one of these numbers, or try and use at least one of those numbers that I'm circling now. And obviously there may be a few others. So in terms of the first one, so 54 is 9 times 6. So again, 9 is the square number. For 28, you can have 7 times 4, which is 4 is a square number. For 48, you've got 16 times 3, where 16 is a square number. Now you could have had 4 times 12, but 16 is a bigger square number, so that one wins. For D, you can have 100 times 3, where 100 is the biggest number. For 180, here you've got 36 and 5. Obviously 36 there is your square number. For 480, you've got 16 times 30, where 16 is our highest square number. For G, you should have 900 times 2. Now though 900 is not on our list, it is still a square number. It's basically 30 times 30. And then finally for H, 847 can be written as 121 times 7. So let's have a look at what is a surd. So a surd is an irrational number that is written in its exact form as a square root. So there are, much like how a rational number is a number that can be written as a fraction, obviously you can have rational numbers, irrational numbers. So rational numbers are basically numbers that cannot be written as a fraction. However, you can write some irrational numbers as a square root. Now another example of a irrational number is pi, but pi can't be written as a square root. There is a value that is pretty close to it, but again cannot be written in its exact form either as a fraction or as a square root. Now the higher level in maths you go, the more essential it is to ensure that you are being as accurate as possible. So rather than writing a really long number or rounding it sort of midway through a calculation, instead we can write it or leave it as a surd. Now just like with fractions, it is possible to simplify surds. However, you can only do this by using the rules of surds. So let's have a look at what the rules of surds actually are. So here, if you've got a number inside a square root, which you can write that as a multiplication of two numbers, then you can split that up with a multiplication in between. So for example, if I had let's say the square root of 48. So I can write this as root 16 times root 3. And obviously from this, I know that 16 or square root of 16 is just 4. So I can write this as 4 times root 3, which can then be simplified as 4 root 3. Because obviously using the rules of algebra, we don't use the multiplication symbol. Now again, if I had a division, then either I've written it as a square root of a fraction or the square root of a division. I can split the two things being divided into separate square roots. So for example, if I had the square root of, let's say, 9 over 4, then I can split this up as to root 9 over root 4. If I had which incidentally would be 3 over 2. If I had, let's say, 16 divided by root 5, and let's say looking at this, then I could, well, let's write that as a single fraction. So let's say I wanted to work out the square root of 16 over 5. Well, I can split that up as root 16 over 5, root 5 I should say. And then do I know what square root of 16 is? Yes, that's 4. Do I know what root 5 is? No. So I leave it as a square root, and there is my final answer. So it's a case of just looking at these two rules, and this is definitely two rules that I definitely would incorporate in your notes. So let's put these more into practice going through some questions. So looking at root 56, and we're asked to simplify this. So again, what you want to do is you want to think of two numbers that multiply to give you 56, and where one of them is a square number. So I could go for like 8 times 7, but fortunately neither of those two numbers are square numbers. I could go for 2 times 28, but again neither of those two numbers are square numbers. But I could go for 4 times 14, in which 4 is my square number, so I can write this as root 4 times root 14. Then I can simplify root 4 to give me 2, and then it will be 2 times root 14, giving me a final answer of 2 root 14. Moving on to question 2. Again, here I want to try and think of two numbers that multiply together to give you 45. So again, I could go for 3 times 15, but neither of those two numbers are square. I could go for 9 times 5, in which that's fine because 9 is a square number. So I could write this as root 5 times root 9. And I don't know what the answer to root 5 is, so I leave that alone, but I do know what the answer to root 9 is, which is 3. And again, I can just simply flip these two things around, giving me a final answer of 3 root 5. Moving on to the third one. Again, I could have 8 times 10, but neither of those two numbers are square. I could have 2 times 40, but again, neither of those are square. I could go for 4 times 20, but again, which is fine, but let's have a look if there's another option, which is 16 times 5. Now, let's just say I went for the 4 times 20 option. So here I had 4 times root 20. And I know what root 4 is, which is 2. But obviously root 20 is not a square number, so I can leave it as that. Now the problem with this is that I can still simplify root 20. So root 20 is equal to root 4 times root 5, which then that becomes 2 times root 5. So here what I've then got is 2 multiplied by these two things, because that's what root 20 is. So I've got 2 times root 5, which then becomes 4 root 5, and there is my final answer. Now if I thought big, so rather than going for the 4 times 20 option, and instead I went for 16 times 5, because 16 is a much bigger square number, then what I'd end up with is 16 times root 5, and the square root of 16 is 4 times root 5, and I get the answer of 4 root 5. So you can see how thinking big, although it gives you the same answer, it's a much quicker way of getting your final answer. You don't need to keep simplifying, just like you would with a fraction. So for example, if I had 20 over 40, yes, I could keep dividing by 2 until I couldn't divide any further, and then I get a half. Or I could just simply think, oh, let's just divide both those numbers by 20, and I get 1 over 2. And you get to the answer a lot quicker. So if you think big, less work. But it's not impossible if you struggle to think of those big numbers. So moving on to the next set of questions. So here we've got root 90 over root 50. Now, there's a couple of options you could have. I could convert this as a single fraction, which is 90 over 50. And I can simplify that fraction to be 9 over 5. Then I can simplify this to be root 9 over root 5. Do I know what root 9 is? Yes, that's 3. Do I know what root 5 is? No. So I can leave it as my final answer. And then just got to ask yourself, can I write 5 as a number that's two numbers that have been multiplied where one of them is a square number? No, I can't, so that there would be my final answer. So with question 5, again, I could write this as, now, does 16 go to 100? No. Can I simplify it? Yes, because they're both even numbers. But you want to think to yourself, well, let's have a look. Well, I should notice that both the two numbers are square numbers. So I can split up as two separate square roots. 100 squared square rooted is 10, and 16 square rooted is 4. And again, I can simplify that to be 5 over 2, giving me a final answer of 2.5 or 2.5, whichever floats your boat. And again, obviously, if I then went on to simplify the fraction, I could have had 50 over 8 square rooted, which is 25 over 4. And then obviously I can't simplify that any further, so I split it up into root 25 over root 4. Root 25 is 5, root 4 is 2, and again I get the exact same answer. So there's different ways in which you do it, all depends on how you're thinking. So again, moving on to this last example here, I can write this, either simplify the 2, so root 36 is just 6, and root 20, well, I've already done root 20, because root 20 can be written as root 4 times root 5. Root 4 is 2, so it's 2 root 5. Now when you've got something that looks like this, what you've got to remember is I can still simplify the 6 and the 2. I can divide both those numbers by 2, so that becomes a 3, that becomes a 1. So all I'm left with is 3 and then root over root 5. And there is my final answer. So what I strongly recommend is that if that all makes sense, why not pause the video and have a go at the following questions. And obviously then I'll just go through the answers. So let's go through the first one. So here, root 5 times root 5, well, I can multiply surds with surds. So then that's just simply going to become root 25, which then becomes just 5. With root 10 squared, well, that means root 10 times root 10. And then I can multiply surds with surds, so that becomes root 100, which then becomes 10. Now, one thing to note is that if you are multiplying or squaring a surd, then basically it just cancels out and the surd just becomes the number that's inside. So here I've got 2 times root 32. So again, I can multiply join the 2, so it becomes root 64, which then becomes 8, and there is my final answer. With question 4, so let me just move down. With question 4, I've got root 498, so I've got square root of 98 over 2, which is basically 49, or square root of 49. 98 divided by 2 is 49, and the square root of 49 is 7. Moving on to the next one, here I've got root 3 times root 5. Now, one thing you don't want to do, well, I can simplify the bracket, so that becomes root 15 squared, and then that then becomes root 15 times root 15, which then becomes square root of 125, or you can just think, well, the square roots are going to cancel because I'm basically squaring it. So for example here, this square root cancels with that square, so all I'm going to be left with is 15. Then moving on to question 6. Now here I've got root 45 divided by 18, so I can write this as 45 over 18. So what number goes into both 45 and 18? That's going to be 9. I can write that as 5 over 2, and then that would be the final answer. It would just be root 5 over 2. Or I could write it as that there. So either of those two answers would be absolutely fine. Then moving on to the next set of questions. So here we just got to cancel and simplify each of these questions. So here, root 18. So again, thinking of a square number as big as possible. So I've got root 9 over root 2, which then becomes 3 root 2. With question 7, I've got root 16 times root 2, which then becomes 4 root 2. With root 20, I've got root 4, well, let's go for root 5 times root 4. Now, it doesn't matter whether the square one is first or second, just got to work it out. So root 5 I can't simplify, root 4 is 2, so that then becomes 2 root 5. And then finally with question 9, I've got this one's going to be, let's go for 400 times 2. And square root of 400 is 20 root 2, and there is my final answer. Now if I did go for the option of 100 times root 8, then root 100 is 10 times root 8, but with 8 I can write that as root 4 times root 2. Root 4 is 2, so that becomes like so, and then I can bring the 10 back, and obviously 10 times 2 is 20 root 2, and I get the same answer. But it's just a case of how quick and how soon you see it. Now the next question is quite an unfamiliar question, but it's something that you still need to be able to do. Now this is where we're working backwards, so this is where we need to write it as a single surd. Now this 3, in order for it to come out of the square root, has been square rooted. Well, that's not right. Square root of a square root. So to get from inside a square root, outside I need to square root it. So to go in the opposite direction, what I need to do is square the number. So here it's going to be root 2, which is the original number, multiplied by root 9. And that then becomes root 18. So there I've written it as a single surd. So for this one, to put it back in there, I'm going to need to square it. So then this then becomes, let me just put a squared. So this then becomes root 3 times root 16, which then becomes root 48. This one here, write as a single surd. Well, here I've got, well, first thing I need to do is change this into a surd. So how do I do that? Well, I can write that as root 9. So then I've got root 45 over root 9, which then becomes root 45 over 9, which then becomes root 5. Now another alternative you could do with question 12, if I just get rid of all of this, is think to yourself, well, okay, let's simplify root 45 and see if that comes up with anything. Well, I can write that as root 9 times root 5 all over 3. Now root 9 is just 3, so it's 3 times root 5 over 3. And then that then becomes 3 root 5 over 3. Now here the 3's cancel, because obviously multiplying by 3 and dividing by 3 just cancels each other out. And then that again leaves me with a final answer of root 5. And you just got to decide which way would I've got the correct answer, and you go from there. Now we'll have a worksheet where you can test everything of simplifying surds from this video, and obviously include the answers so you can check to see if you are getting them right.